Hello and welcome guys. So in the last video, we discussed about this project at high level. So we saw that how we can develop a movie review sentiment analysis classifier. So for that, the dataset we are using from the Kaggle. So let me go to the Kaggle. I have provided the link of this dataset in the description. You can take from there. So once you open this link, you can download this dataset from here. Okay. And in this data set, we have two columns. One is review and second one is sentiment. So review contains all the reviews given by the user, and sentiment is the what is the sentiment of these reviews. Okay, so this is the sentiment. So it's saying that it's positive, and somewhere we are also getting negative. So here if you see, we have two unique values, positive and negative. So that is our data set. I have already downloaded this data set. So I have created here one folder, movie review sentiment analysis folder. So in this folder we have here imdb dataset.csv, and I have prepared one basic text processing notebook here. So in this notebook you will get all the details of basic text processing. So what are the different techniques which you can use to clean your text. So let me open this notebook. Okay, so this is the notebook. So here if you see, we have different techniques. What are the different techniques to clean our text? So everything you will get here. So first let me tell you what is text processing and why it's needed. So text processing is a crucial step in sentiment analysis, or you can say any NLP task, because raw text often contain noise that can confuse machine learning or deep learning model. So basically, if you feed any raw text directly to your ML model or deep learning model, then your model will not be able to capture the important feature from that text. Okay, so this text processing is a technique to extract only the important words from that sentence and feed to your machine learning deep learning model. Okay, so let us understand this with some example. Like here I have taken one sentence that the movie was absolutely wonderful and I loved every moment of it. So in this text, if you apply all this pre-processing, which we are going to see later, so after that you will get the final thing like this: movie absolutely wonderful, love every moment. So these are the important words in this sentence. This the, was, and this comma, and I, and of, it, these are not important words. Okay, so to understand the sentiment of this entire sentence, what our mind is focusing on, okay, so user is talking about movie. Okay, so movie is important, and absolutely wonderful, so these are the important thing, and user is loving it. I love every moment, so love is important and every is important. So these are the important things which our mind is like, if I am reading this, then our mind is doing some computation and it's thinking in that way. So in the same way, we have to train our deep learning model also. Okay, so that's why it's important to extract the relevant information from it and feed to our model. Okay, so in this text processing, first step is the lowercasing of the word. I have attached one example here, like I am happy. So if you do the lowercasing of this, then you will get like this. So in Python, if you want to do that, then let's create one variable here. Like let's take it from here only. So I'm taking it from here. I'm happy. Okay. So let's copy here. Okay. If you want to lowercase this entire sentence, then you have to use this function. Text.lower you have to apply. So once you apply this, then you will get this in lowercase form. Okay, so this entire happy converted in lowercase, and this I is also now lowercase. Okay, so you have to apply this function. This is a basic function of Python. So text.lower if you use, then you will get things in lowercase. Okay, so why we are doing this, we'll understand later. Okay, the second step is we have to remove the punctuations. So first let us understand what is punctuation. So to show you exactly what is punctuation, I'm importing string here, and I'm doing here string dot punctuation. Let me print it. So these are the punctuations. Okay, this exclamation mark, this double quote, hashtag, dollar, percentage. So these are punctuations. Okay, this punctuation is not important because it will not represent any important feature. So we have to remove it. So to remove punctuations, like I have taken here example also, like I'm happy and exclamation mark and question mark. So after removing it in this final form, we are not getting any exclamation mark and question mark. So to do that, first I am defining here one variable. This punctuation is equal to. So if I print this punctuation, then you will get punctuations like this. Okay. So after that, I will use the same example. So I am copying this from here. Okay. So I'm pasting here, and after that I have to remove it. So for that, what I will do, I will iterate over each character, and I will try to match it with this punctuation. And if it's matching, then I will not take that, and whatever things are not matching, I will only consider those character. Okay, so that is a simple logic. So let me do that. Let me create here one list. So I'm using char, and I'm iterating using char for char in text. So if I print this, then what you will get each character like this. Okay, so what I am trying to say here, take only that char which is not in punctuation. I'm saying this. So after this, if you will see that we are not getting any punctuation, we have to convert it in this string form like this. So for that, I will join it. So for joining, I will say that whatever is the format, in the same format, join it. So this is a basic join technique. So using this technique, you can convert your list in string. So I'm saying that use whatever is there in the list and just join it. Okay. So this spaces are coming from the list. Okay. So everything we are joining it. So that is the only thing here we are doing. So if I write here like without punctuation as an example, without punctuation. So if I print this variable, then you will get here this new text without punctuation like this. Okay. So now next step is tokenization. So tokenization means that split the sentences into individual words. So like here, this is one example, like I love this product. So if we apply tokenization on this text, then we'll get I love this product like this. Okay. So this is by like this you can do tokenization. So for that, again, I'm using the same example from here. Okay. And if you want to apply tokenization, then you can use here text dot split, and if you use this, then you will get here like this. Okay, whatever we are. So here we are getting I love this product separate, and this split, what it exactly it's doing, it's if you see this from here, you will see that when set to none, so default value is none for the separator, so we are not applying any separator. So it will split on any white spaces character. Okay, and will discard empty string from the result. Okay, so like if I give here multiple white spaces like this, again we'll get the same thing. So it's splitting based on white spaces. Using NLTK also you can tokenize it. So let me give that. So first let me import that tokenizer. Okay, so from NLTK dot tokenize, I'm importing word tokenize. Okay, and I'm using the same text, this text. I love this product, and you can use here word tokenize, and you can pass this text. Okay, so it will give you this I love this product. So by using this NLTK pre-built word tokenize, also you can tokenize your text. This will be your tokens. So same here also you can write. So this is your token generated after applying text dot split, and this is a token you are getting after applying this word tokenize. So there are more techniques, like you can use regex also. Regex is also one Python package which you can use to split your sentence into words. So here I would like to highlight the power of this NLTK word tokenize. So let me take one example here. Like I'm taking here one example that hello world. Okay, I'm taking this example, hello world. So if I apply on this, if I print text dot split here, so let's see what is happening. So here we are getting hello and here world, but world with exclamation mark here we are getting. Okay, so it's treating it as like one word, this world with exclamation mark. it's not understanding that world is different and exclamation mark is different thing. Okay, so it's not understanding these things. So if I use on the same example, if I use again but this time NLTK tokenizer, then let's see what is happening. So I have already imported here word tokenize, so I'm using directly here NLTK word tokenize and I'm passing this. So here we are getting hello world and exclamation mark separate. Okay, so this tokenizer is much intelligent than that one, because here we are not here we are just splitting it based on spaces, so there is no logic involved here. But here it has the knowledge of vocabularies and word also, so it's understanding that world with exclamation mark is nothing. Okay, so it's irrelevant thing, so it's separating that world with exclamation mark, so it's giving us hello world and exclamation mark separate. Okay, so this is a much efficient way to tokenize your sentence as compared to split, or you are applying any regex and anything. It has some word knowledge also, so that's why it is much intelligent as compared to any logic we are applying based on white spaces or something. Okay, now we'll see the how we can remove the stop words. So first, what is stop word? So stop words are like is, am, the, in, and. So these are the frequent words that don't add much meaning for tasks like sentiment analysis, and removing them help reduce noise. Okay, so like we have seen here also, like the movie was absolutely wonderful. In this was and the, it's not making any significance on the sentiment of this sentence, so that's why this stop words are not much relevant and we have to remove it. Okay, so I have taken here again one example, like I am very happy with the service. So in this, if I remove the stop word, then I will get only happy service. Okay, in this sentence, this happy and service are the deciding factor which is deciding the sentiment of this sentence. So let me take again this example from here, and now I have to remove the stop word like I am, these things. So first I have to import NLTK, and then first I have to find all the stop words which are present in English. Okay, to find that you can use nltk.corpus, nltk.corpus, and you can use nltk.corpus.stopword you can use, and in stopword you have to go in words, and inside this word you will get English. So if I print this, then you will get the list of this stopword presents. Okay, like here a, about, above, after, again, against, in, all, am, and. Okay, so these are the list of stopwords present in English language. So we can take this from here. So let me define one variable here, stopwords. So in this stopword we will get everything. And one thing here, if you notice, everything is in lowercase, nothing is in uppercase. Okay, so this is also one thing, because of that we have to do things in lowercase. Okay, because we have to follow one standard procedure in which if we put everything as lowercase, then capital I and small I will be treated as single unit. Okay, and if things are like uppercase, lowercase, then language model will understand that okay, capital I is something different and small I is something different. Okay, so if we make everything in lowercase, then model will easily understand, okay, so this I and this I is same thing. Okay, so that's why also it is important. So we got our stop word. After that we also have our text. So first we have to tokenize it, but before that we have to lower also. So I am defining my tokens here. So I'm using here word tokenize from NLTK, and in this I will first lowercase it. So directly I will lowercase here only. Okay, so I am converting it in lowercase and then I am applying this word tokenize. Okay, so let me print this token here. So here I am getting I am very happy with the service. Okay, so we got our token, and now what we will do, we will remove the stopword from here. So if I print this stopword, so we have this list. So we have to remove those tokens from here which are part of this stopword. So for that, what we have to do, first use the list comprehension technique. So for char in don't use char, I will use word. Okay, for word, so I will iterate over word of this token. So for word in tokens, and I will say that if word not in, consider those words which are not part of stop word. Okay, so this is a small thing. So after this you will get here happy service. Okay, so if we want the like this, then I can join it. So I will use join here like this. So I will get happy service. Okay, so here if you notice, here we have to give space because after tokenizing we it's directly joining it. So I'm giving here one space, so we'll get here happy service. Okay, so this will be our after removing stop word thing. Okay, so let's define one variable here, and this will be your after removing stop word. So like this you can remove the stop word from the text. So first load all the stopwords present in English. So to load that you can use NLTK.corpus. From there you can load your stopwords, and after that word tokenize you can use. And one more thing here, if you are getting error while loading this NLTK stopwords, then you have to run this command. Okay, so if you don't have NLTK, then first please install this NLTK like this, pip install NLTK, and you have to download this stopwords, and later we are going to use Lemmatization also. So to download that Lemmatization you can use here nltk.download wordnet, and for stopword you can use nltk.download stopword. So it will download all the stopwords from the corpus. Okay, so you can run directly here. So once you run this, you will get here like downloading package. If you're doing for first time, then you will you will get something, and then it will say that okay, things are downloaded. Okay, after that only run these things. Okay, so we already completed this removing stopword part. Now we'll see the stemming. So first, what is stemming? In stemming, what we are doing, we are cutting off prefixes or suffixes to get the root form of word. So here, like if we apply stemming on this playing, then we'll get play. If we apply stemming on played, then we'll get play. And if we apply stemming on this flies, we'll get fly. So if you notice, it's cutting this ing from here, and here it's cutting this ed, and here it's cutting this es. So it's cutting some part. Mainly it cut it cut things like ing, ed, es, and these are the things mainly it cut. Okay, so to apply stemming, first you have to import it from NLTK. So you can use nltk.stem, and from there you can import Porter stemmer. So Porter is one researcher who developed this stemming, so that's why they have given the name that Porter stemmer. Okay, so you can load your object here like this, Porter stemmer. So this is st is your object, and to apply stemming, just you have to, if you want to apply stemming, then you have to use here st.stem, and in this if you pass this playing, then you will get play. Okay, and in this if you pass played, you will get play again. In this if you will pass flies, you will get, oh sorry, not files, flies, you will get fly like this. Okay, so this is like this in Python you can implement stemming. So let me write here, what we are doing here, we are doing stemming. Okay, and here we are using this word as playing. We are converting it in we are applying stemming on this, so you can apply like this. So here I am giving one string, so playing, so playing become play, and after that let me apply it again for other two. So playing become play, played become play, flies become fli. So fli is not a real word, it is something which it's converting. It has no knowledge that after stemming whatever word will get generated, whether it is relevant or not, it has no knowledge of that, but it is quick. Okay, so if you see here, I have written that a quick and dirty way of shortening the word. And when speed matters more than accuracy, like in search engine, where like on Google, if you're searching something, then there you want quick response. There you can use this stemming technique, where based on your keywords, based on your words, Google will try to suggest you that these are the possible links which you can visit. Now let's discuss quickly about this lemmatization. So how we can apply lemmatization and what is this lemmatization? So lemmatization is also similar to stemming, like convert a word to its dictionary form, considering its meaning and part of speech. So whatever things are not getting satisfied here, same that problem is getting solved in lemmatization. How it works? So it uses vocabulary and grammar rules to return real word. And here uses simple rule to chop off word endings. It does not check if the result is valid word. Okay, so stemming doesn't check anything like whether that word is valid or not. But here it uses vocabulary and grammar rules to return the real word. Okay, and you can think of it as a smarter and more accurate version of stemming. So the same what I'm saying, the same thing is written here. And where it's used, like here it used mainly when understanding and accuracy matter, like in chatbots, NLP pipelines, like in sentiment analysis also, where understanding of words matter. Okay, so here we have to find extract the relevant thing. Flies means something. Okay, FLI is nothing. So here, to solve any NLP problems, or if you're building any chatbot, then this lemmatization will be more impactful as compared to this. Okay, so to use the lemmatizer, first I already told you that we have to download this NLTK.download WordNet. So we are going to use WordNet lemmatizer. For that, first we have to import that WordNet lemmatizer from NLTK. So I'm using NLTK.stem. Same here also we used NLTK.stem and we imported this class porter stemmer, and here from NLTK.stem we'll import WordNet lemmatizer. Okay, and I'm defining my WordNet lemmatizer like this, and to apply something like this to just like stemming, here we have to use lemmatize. Okay, here we are using st.stem, here we have to use lm.lemmatize, and in this we can pass something like let me pass playing. So for playing we'll get same, playing is playing here. Okay, playing is not play. So it has knowledge of grammar, it knows that playing is something else and play is something else. Okay, so if I do here played, we'll get played, we will not get play like in stemming. Okay, and if I use this flies, and let's see what we are getting. So we'll get fly. For this flies we'll get fly. Okay, so it's transforming it in much better way as compared to that stemming. Okay, FLI is nothing, but here it's transforming its understanding. Okay, fly is okay, so I will cut it, but I will cut to fly. Okay, so that's the thing. So here if I use these things like in this example, and also this better, so better is better here. Why I have written here good, I don't know. I think it's better. Okay, better. Oh, somewhere sometimes in previous versions it's saying good, but it's better. Okay, so same way we can run this entire thing here also. So I'm going to use here lm.lemmatize, and here also lm. Okay, so playing will be playing, played will be played, and flies will be fly. Okay, so like this you can use and apply this lemmatization on your text. Okay, so I hope you understand the basic text processing, how we can perform basic text processing on your sentence. So once you apply all these techniques together, then you will get your final form like this. Okay, like in this text. So this lowercasing is important to standardize your data. Okay, so that's why we are doing lowercasing, and then we are removing the punctuation, because punctuation will not make any impact in sentiment analysis. Okay, or any NLP task, it has no relevance. Sometimes it has relevance, but here it's not. So we have to remove that. And this tokenization also, we are doing this tokenization to convert and get the each word, because here we are going to build our model word by word using word. So that's why we have to split this in word. So, and also we have seen the difference between that how it's better than text.split, and then this one, how we can remove stopword from our sentence. So like this you can remove the stopword, and these are all the list of stopword, and this is all about stemming and lemmatization. So in stemming, we are blindly chopping off the word endings and getting our word whether it is relevant or not, we don't know. And in lemmatization, it's much accurate and smarter version of stemming, in which it uses vocabulary and grammar rules. It has knowledge, it is understanding, okay, playing and played is different. So this is all about the basic text processing technique. So I will attach this text processing notebook also to my GitHub repo, so you can refer from there. So this is all about basic text processing, and in the next video we'll apply these concepts and develop our clean text function, and we will apply these all the text processing technique on our data set, which is this one, IMDb data set, and then we are ready to build our text vectorizer and all. Okay, so that's all for this video. I hope you like this video. Thank you guys, thanks a lot for watching this video.